This is a rough guide to the normal distribution. Now, it's quite possible that the normal distribution is the most commonly used probability distribution in all of stats. Okay, that's got a good chance of being that way. I haven't gone out and counted it, but tell you what, it's everywhere. So normal distribution might have a graph of that shape, alright, and it has some very distinctive features. Okay, I've got a bunch of them listed there. It's got a symmetry, it's got what's called a bell shape. Alright, they often get called the bell-shaped curve. Okay, so there's an example of one, but there's variations on that. For example, different size peaks and different sort of spread. We'll have a look at that in a minute. Symmetry, bell-shaped, unimodal, it's got one mode and that's at the center. Okay, it's got one value, that's the most common. Okay, and we'll get on to that too in the next couple of videos. We've got the mean, the median, and the mode. All of them are equal and they're both located at the center of that distribution, as we saw from the peak there. And in future videos we're going to be looking at this, but if we look at a standard deviation as one standard measurement of distribution, about 68% of the data falls within one standard deviation of the mean. So remember, the mean is in the center and one standard deviation either side. That will contain 68% of the data. Okay, so 68% of the scores will be in there. Okay, so look at that terrible coloring in. I don't care. So we've got, and I don't care what color I've used either, so 95% will fall within 2 standard deviations, and 99.7% of all the data falls within 3 standard deviations. That's nearly everything. Okay, so 2 and then 3, you've got just about everything there. Okay, see, I told you it was going to be a rough guide. That's pretty rough. I deliver. Okay, examples, it's everywhere in the world. Blood pressure readings for people, the birth weight of babies, IQ score, entrance exams, and so on, standardized tests. Okay, variations, as I mentioned a minute ago, graph 1's a variation and it has a mean and a standard deviation of 0.5, a mean of 1, that should say. Don't know. Oh, -1. Sorry, -1 below average. And that's a standard score, which we'll talk about later. Graph 2 is a mean of 0 and it has a standard deviation of 1. Notice that it's more than that one. Okay, and you see that graph 2 is much broader, yet it's lower. Okay, it's more widely distributed, yet they're all still normal distributions. Graph 3 has a much higher mean. Look, 3, and it towers above the other two, but its standard deviation is quite narrow. Okay, so that means that it'll peak quite high, and because it has a mean of 3, it's much further down there. Okay, we're going to have a final look at all this stuff as we go. The central peak is always at x equals mu. Okay, so the mean is at the center. Mu being the mean from our previous work, it's at the center. Okay, alright, in our rough guide, the next thing, this formula we're going to be using and adapting this for normal distributions. You can see it there, some of which will be familiar, some of which won't, and that E there is the transcendental number E. Mu is the mean, and this refers to the scores, and that sigma the standard deviation, and we'll expound on that in future videos, but make sure you take a copy of that one there. And normal distributions are defined by 2 parameters. Alright, 2 things we can change: the mu mean and the standard deviation sigma. Alright, these distributions are symmetrical around the mean, the median, and the mode are all equal, and the majority of the values are located around the center of the curve, with much fewer spread out from the center. The area under the curve is 1, evidenced by that integral from -infinity to infinity. To finish off our rough guide, and there will be more, so join me for the next one. In general, if x is a continuous random variable that follows a normal distribution, the mean is mu, the variance is the square of the standard deviation. Okay, it's written like this. Okay, there's some notation to get used to. N for normal, x referring to the random variable, mu the mean, and sigma squared is the variance. Okay, so that will be used in future videos and in some of the work we do. Okay, the probability density function, it will be given by that equation we just saw, that one there. Okay, so more about that and a less rough guide next time. See you then.